Hi everyone, we're solving this physics paper today. This is 9702, paper 13, May June 2023. The time is 1 hour 15 minutes. So before we begin, let's take a look at the threshold. So for this paper, here we go, component 13. Maximum mark is 40 and here are the marks. It actually had the same difficulty as paper 11, the one I solved in my last video. So let's just write this down. 40 was the maximum mark. A was at 29, B was at 25, C 22, D at 19, and E at 17. So as you can see from the marks, A star should be at around 3 to 4 marks greater than this. So maybe either 32 or 33, somewhere around there. A star should be there, okay? Without further ado, let's begin. But I just want to talk about my Patreon. I'll give a link in the description. If you choose to support me there, you get access to all these solved question papers for physics, chemistry, and bio paper 1, 2, 4, and 5, as well as math P1, P3, mechanics and statistics M1 and S1 for the middle tier. And for the highest tier, you get access to video meetings with me where we can solve your problems individually once or twice a month. Anyway, let's start. What must be included in a record of a physical quantity? So what do we need? Um, we basically need a numerical value. Okay, we need a numerical value along with its unit. But we do not need the base unit. It doesn't have to be the base unit. We need a numerical value. Okay, so it does not need unit expressed in base units because we can keep Newton, that's fine. We do not need an SI unit. It can be in kg, it can be in grams. It doesn't need to be an integer. It can be 2.1 or something like that, okay? So it just has to be a numerical value for the quantity. It doesn't have to be an integer. Any numerical value will work, okay? So next, what is the ohm expressed in SI base units? Let's try doing this. So we know that V is equal to IR, or R is equal to V by I, and we also know that V is equal to work done per unit charge. So work done per unit charge, what is that? F into D by Q. So that's kg ms minus 2 times meter divided by Q is equal to IT ampere seconds. So V is basically kg m square s minus 3 ampere minus 1. Okay, that's V. Now R is V by I, so that is essentially the whole thing and divided by another ampere, so that's kg m square s minus 3 ampere minus 2. Kg m square s minus 3 ampere minus 2, so 2 is A. A desk has a true width of 50 centimeter. Two students X and Y measure the width of the desk. Student X uses a tape measure and records a width of 49.5 plus minus 0.5 centimeters. Student Y uses a meter rule and records a width of 51.4 plus minus 0.1 cm. Which statement about the measurements of student X is correct? The true width is 50 centimeters. Sorry. The true width is 50 centimeters. Okay. So student X uses a tape measure and records a width of 49.5. So if you compare the distance from 50, what's the gap? 0.5 is the gap, and here it's 1.4. So student X is more accurate actually, because his or her answer is closer to that of, you know, the true value, which is 50. So it is more accurate, not less accurate, clearly. But let's talk about precision. So both of them record to one decimal place. Okay, both of them are recording to one decimal place. However, the uncertainty of student X is much higher. Okay, because it could vary from 49 to 50. But check this out. For student Y, the precision is greater because it varies from 51.3 to 51.5 within a very small range. If the range of values is very small, we say that the answer is very precise. So Y is more precise. So X is more accurate, however, less precise than Y. Okay. Diagram shows two vectors x and y drawn to scale. If x equals to y minus z, which diagram represents the vector z? So it's y minus z. So it's if we make z the subject, x equals to y minus z, so z is equal to y minus x. Okay, so we go for y over here. Let me move this working somewhere else. Plus y, and since x plus x is like this, minus x will be something like this. This is minus x, and the resultant value should be something like this over here. So I'm looking for something like this, and that matches with 4a. Okay, so I just took plus y to the right, and minus x will be in this direction. Okay, basically. Next, number 5, which equation representing uniformly accelerated motion in straight line can be determined using only the definition of acceleration? Okay, so acceleration is defined as the rate of change of a velocity. So a is equal to v minus u by t, or at is equal to v minus u, or we can just say that v is equal to u plus at. That is simply it. So 5 is C. Next, number 6, an object moves from rest with uniform velocity horizontally and uniform acceleration vertically. Projectile motion, basically. Which graph shows the variation with time of the displacement of the object from its initial position? Which one is correct? Okay, so essentially what happens is, think about it, it's a projectile. It has uniform vertical, sorry, it has uniform velocity horizontally and uniform acceleration vertically, and it moves from rest. Okay, so it moves from rest. It's a bit different from projectile actually. I just erased the color. Wait, yeah, here you go. Okay, so as I was saying, we start from rest, keyword, uh, with uniform velocity horizontally and uniform acceleration vertically. So it's like a horizontal projectile. Okay, so suppose it's an object over here and it's released like this. Okay, it has uniform acceleration vertical downwards and constant horizontal velocity. So which graph showing the variation with time of the displacement is correct? So for horizontal displacement, this is wrong. Since it has constant velocity, horizontal displacement should have been a straight line. That's why A and C are wrong. It's between B and D. Now, which one is correct for vertical displacement? As you can see, it is accelerating, so its displacement will increase over time. It will have an increasing gradient because there is acceleration. If there was deceleration, the answer would have been B. But since there is acceleration, the answer is D. Okay. Oh, this is a common question which has appeared before in A levels. A device for spraying paint consists of a box with its faces horizontal and vertical. One of its vertical faces contains small holes. Paint is fed into the box under pressure via a vertical tube and exits through the holes as fine streams moving horizontally. The paint is ejected at a speed of 2.5 meters per second through 400 holes, each of area 0.4 millimeters square. The density of the paint is 900 kilograms per meter cube. What is the horizontal force required to hold the device stationary as it ejects the paint? Okay, so as you can see, it's going to exert a force like this through the holes. So um, we also need to provide an equal and opposite force. Basically, when the paint comes out, right? When the paint comes out like this, there will be a force experienced uh, by the device like this, kind of like a speedboat. It actually pushes the water behind, which causes it to go forward. So Newton's third law. So similarly, as the paint comes out, it will actually feel a force behind. So to keep it in, keep it in place, we need to provide a force in the opposite direction. Now here's the thing, whenever you see velocity and they're talking about force, you need to refer to the definition of force, which is the rate of change of momentum. You guys already know that F is equal to del mv by del t. Now this is happening in 1 second. So this is speed. Now to 400 holes, density of the paint is this. What is the horizontal force required to keep it stationary? Okay, so you guys know that density equals to mass by volume. So mass is equal to density times volume. Okay, so as you can see, you have the area of each small circle over here. And if you think of the area like this, and the paint is ejected like this at a speed of 2.5 meters per second. So it's actually forming a cylinder, right, of speed 2.5 meters per second with cross-section area 0.4 millimeters squared. So we can actually find out the volume of paint being ejected per hole. So if you think about the volume, what's it gonna be? It's basically pi r square h. That means the area times the height being the velocity through which the paint is moving, because it's being traveled in 1 second, right? So if you think of the volume, it's actually the area is zero point 0.4 into 10 to the power minus 6, because it's millimeter square, times the height is going to be 2.5. That's your volume for one um, hole, and you have 400 holes, so that will be multiplied by 400. So the ultimate mass will be the density, which is 900 times 400 times zero point 0.4 into 10 to the power minus 6 times 2.5. So that gives you this answer of mass. That gives you this answer. Okay, that's good. Now we have the mass now, and this all of this is occurring in 1 second, by the way, because we know that this 2.5 refers to the length moved by the paint per second. Now if you input it here, F is equal to 900 times 400 times zero point 0.4 times 10 to the power minus 6 times 2.5 in 1 second, multiplied by the velocity, which is 2.5, we are going to get our final answer. So let's try doing this. 900 times 400 times zero point 0.4 into 10 to the power minus 6 into 2.5. That 2.5 is due to the height, because the liquid is being ejected at 2.5 meters per second, and the one later is for the formula of momentum. Okay, so answer into 2.5 again, which gives us a value of, wait, let me calculate, 0.9 newtons. And yeah, that matches with B. That is the answer in the mark scheme. Okay, that's good. So yeah, pretty complicated sum. This has appeared in the past, but it's pretty hard for a candidate doing it the first time. Next, number 8, each diagram illustrates a pair of forces of equal magnitude. Which diagram gives an example of a pair of forces that is described by Newton's third law of motion? Okay. Clearly, it is B. We solved a similar question in variant paper 1-1. Basically, it has to be of the same type, number one. And since the Earth is pulling the moon with a gravitational force, the moon is also pulling the Earth with a gravitational force. Number 9, two balls. By the way, why are the others wrong? Because they are not the same types, okay? They might be equal, but they are not of the same types. They might be equal, might have opposite directions, but they have to be of the same type, okay? That's the main fact. Number 9, two balls of identical shape and size but different masses are falling through the same liquid. The sum of the drag force and upthrust acting on each ball is equal to its weight. Which statement about the two balls is correct? The heavier ball has a larger acceleration than lighter ball. The sum of the drag force and the upthrust is equal to its weight. But hear me out. The sum of drag force and upthrust is equal to the weight. So there is no net acceleration, right? There's no net acceleration. They are moving at constant speed. So we can't talk about these. A and B are wrong, because acceleration is totally out of the equation. It's between C and D. It's just that since the larger ball, right, although they're flowing through the same liquid, they have identical shape and size. Oh, they have identical shape and size, but different masses. This is heavier. Suppose this is 2m and this is just m. So this one falling down is, for this one, it's 2 mg is equal to, volume is same, rho is same, v rho g plus upthrust, and sorry, that is upthrust, v rho g is upthrust plus the drag force, and for this one it's mg is equal to v rho g plus the drag force. This is how it's being balanced out. Now here's the thing, the heavier ball will take longer to reach terminal velocity. I'll tell you why. Because for both of them, this upthrust is the same, v rho g. V is the volume of the object, rho is the density of the fluid it's in, g is 9.1. But since this is higher, drag force has to go up a notch higher, right? To balance 2 mg. But for the smaller ball, mg will be balanced quite easily by the drag force. So the heavier ball actually reaches a higher terminal velocity, so the heavier ball is falling at a larger speed than the lighter ball. A bit complex, it's a complex explanation. Next, number 10, a perfectly elastic collision occurs between two objects x and y. The mass of x is m and the mass of y is 4m. Object x travels at speed v before the collision and speed 3v by 5 in the opposite direction after the collision. Object y is stationary before the collision. What is the kinetic energy of y after the collision? Okay, so let's do momentum first. It's an elastic collision, by the way. Oh, so we can do this pretty simply because the speed of approach must be equal to the speed of separation. The speed of approach is simply v. So the speed of separation, 3v by 5, plus this unknown vx must also be equal to v. Why am I adding it? Because the logic is, if you move in opposite directions, you add it. So x is equal to v minus 3v by 5, which is 2v by 5. Okay, so this is 2v by 5. I applied the relative speed of approach and separation. Since it's an elastic collision, I could do this relative speed of approach is equal to relative speed of separation. Okay, okay. Now let's find out the kinetic energy of y after the collision, which is half into mass 4m times 2v by 5 whole square, which is half into 4m into 4v square by 25. Okay, so 4 into 4 by 2 by 25, which is 8 by 25. 8 by 25 v square, actually 8 by 25 v square. 8 by 25 is actually, this is the same answer. If you multiply it by 2, they just didn't, they just didn't simplify it. So it's basically 16 divided by 25 times 2, which is 50. 16 by 50 v square. Okay, that is the answer, 10C. What is not a requirement for two forces to act as a couple? Okay, so sorry. What does a couple have? Basically, it has two forces, equal magnitude, acting in the opposite direction. So this is a requirement. 11b is wrong. They do not need to act through the same point. Okay, they can act through different points. It's not a requirement. Okay. For number 12, we have uniform meter rule, which is pivoted at the 34 centimeter mark, is shown. The rule balances when a 64-gram mass is hung from the 4 centimeter mark. What is the mass of the meter rule? Okay, so we know that this is a uniform meter rule, so the weight will act through the center like this. It will provide a clockwise moment. So what is the gap between this? It's 16 centimeters. Okay, so and what about the gap here? 34 minus 4 is 30. So what can we say actually? We can go for the anti-clockwise moment, which is 30 times 64 is equal to the mass. Okay, by the way, we need to use weight actually according to the formula of momentum, which is F into T. So 64, I'm not converting it to kg because it's grams on both sides, into 9.81 mg into distance in centimeter is equal to the mass into g, which is 9.81 times 16 centimeters. Okay, so if we do the working properly, we can get rid of this. M is equal to 64 into 30 by 16. 4 3s are 12, so it's 120. 12 should be C, and the answer is C. Number 13, the volume of 1.5 meter cube of water is mixed with 0.5 meter cube of alcohol. The density of water is 1000 kilogram per meter cube. The density of alcohol is 800 kilograms per meter cube. The volume of the mixture is 2 meter cube. What is the density of the mixture? Okay, interesting. So remember that density will be divided according to the ratio of the volume. Okay, density will be divided according to the ratio of the volume. The total volume of the mixture is 2 meter cube. Okay, so I think we should do this. Let's go for it. So the total density will actually be, so for water it's 1.5 divided by 2 times 1000, this is for water, plus 0.50 divided by 2 times 800. So 1.5 by 2 times 1000, sorry, 750, plus 0.5 by 2 into 800. The answer is 950 in total. In total, it's 950. This is how you do the sum. 13 is D. Let's go to 14. An object is falling at a constant speed through a viscous liquid. Fu is the upthrust on the object due to the liquid. W is the weight of the liquid displaced by the object. W is the weight of the object. Okay. Which equation must be correct? Since the object is falling at constant speed, we know that it has a weight downwards like this, and it has upthrust like this. And since it's passing through a viscous liquid, it obviously has some, you know, it should have some drag force, but they haven't mentioned that, right? So since it's passing through um, at constant speed, the net force must be 0, or upward force must be equal to the downward force. So here, since they've only mentioned the upthrust as the upward force, it must be equal to the weight. But I just told you that even though they don't mention it, right, there is actually a viscous drag acting upward. So the actual formula should have been drag plus upthrust is equal to weight of the object. So if there was this equation, we would opt for it, but I am not seeing this equation. Now next, weight L. WL is the weight of the liquid displaced by the object. What does this mean? So you guys know the formula for upthrust, right? It's V rho G. Now you also know that density equals to mass by volume. So here the rho refers to the density of the fluid that the object is moving in. So it's mass by volume. I can replace this density by mass by volume into G. So we can get rid of V, and we ultimately end up with mg, the weight of the liquid or the fluid that was displaced. So we can actually say that Fu is equal to the weight of the liquid that is displaced. So yeah, A is a probable answer. Interesting question. I haven't seen this before. By the way, guys, if you do like the content or find the content helpful, please do subscribe to the channel and like the video. It helps with the algorithm a lot. Also, you can consider supporting me on Patreon, where you get access to all my notes for AS and A2 physics and chemistry, and solved papers for bio, chemistry, and physics paper 1, 2, 4, and 5, as well as math P1, P3, M1, and S1. Also, for the highest tier, you get access to video meetings with me once or twice a month. I'll add a link in the description so that you can check it out. Okay, moving on. Question 15. An airport has a mechanical system for moving luggage. The system uses a horizontal conveyor belt, a sloping conveyor belt, a lift, and a frictionless slide. A suitcase is moved around the airport using the system. Resistive forces opposing the motion of the suitcase are negligible. For which movement of the suitcase is the net work done on the suitcase greatest? Okay, so all of them are at constant speed except the last one. So here it's getting GP, so it's going to be mgh. So it's 10 mg over here. For which movement of the suitcase is the net work done on the suitcase greatest. When it's moving 16 meters at constant speed, it has no net work done, no Ke increase, no Gp increase. And for this one, it only has a small height, clearly less than 10. Clearly less than 10. So it's probably the 10-meter one, okay? This is the answer. I'll tell you why not the last case, because here, what's happening? It is getting an increase in Ke, but the Gp is also decreasing. So some Gp is being converted to Ke. And look at this, it doesn't even reach the ground. It reaches up till this height. So it doesn't really travel 10 meters. It travels something like 7 or 8 meters. As a result, the net GP, uh, the change isn't the same for the 10-meter and 12-meter one. And clearly the 10-meter one is higher. Number 16, a car moves along a horizontal road with constant velocity V against resistive force F. The efficiency is 25% of the engine. What is the input power to the engine? Constant velocity. So we can say that the driving force is equal to the resistive force F. Now we know that, there's a power formula for power. P is equal to Fv. So the driving force is actually equal to power by velocity. So we can write P by V is equal to the resistive force. Now the engine of the car has an efficiency of 25%. So I'm finding out the output power at first. Okay, so the output power is equal to F times V, resistive force into velocity. Now we know that the efficiency, what is the formula for efficiency? Is equal to useful output by input into 100%. So we know that the efficiency is 25%. So 25 by 100 is equal to the output power, which is Fv, and we don't know the input. So input equals to Fv into 100 by 25, which is 4 times Fv actually. So 16 is C, 4 times Fv. Okay. Next, an object of mass 0.4 kg is projected into the air and follows a curved path above horizontal ground. The object takes a time of 1.5 seconds to move along its path. The object lands a horizontal distance of 18 meters from its initial position. Air resistance is negligible. What is the kinetic energy of the object at the maximum height? Okay, so clearly you guys remember that the maximum height, it does not have vertical velocity anymore. It only has horizontal velocity. Okay, so it takes 1.5 seconds to travel this distance. So we can actually find out the horizontal displacement using S equals to Vt. So 18 is equal to 1.5 times V. So 18 by 1.5 is 12. V is equal to 12 meters per second. That's the horizontal velocity because it remains constant throughout. Now, kinetic energy at max height. Here, the vertical velocity, the component is 0. So the Ke will be half times mass 0.40 times 12 square only. So 12 square into 0.4 into 0.5 gives you an answer of 28.8. So the closest answer is D. 17 is D. Okay. Number 18. A metal wire has length 5.2 meters and diameter 1 millimeter. The metal has a Young modulus of 360 gigapascals. The wire is fixed at one end and a force is applied to the other end. The force extends the wire by 7.2 millimeter. The wire obeys Hooke's law. What is the force applied to the wire? So we know that the Young modulus is equal to stress by strain, or FL by AE, right? Now we want to find out the force. So force is going to be equal to the Young modulus into A small e extension by L. Let's do this. So 360 into 10 to the power 9 times the area. We have the diameter. We can find out the radius. It is 0.5 millimeter. So it's pi r square, pi into 0.5 into 10 to the power minus 3 whole square, pi r square. Okay, pi r square times the extension. So the force extends the wire by 7.2 millimeters. So this is the extension, 7.2 into 10 power minus 3 divided by the original length, which is 5.2 meters. Okay, so let's do this. 360 into 10 to the power 9 times pi times 0.5 into 10 to the power minus 3 whole square times 7.2 into 10 to the power minus 3 divided by 5.2. Okay, so I'm getting an answer of 391.5. So what's the closest answer? 3.9 into 10 to the power to 18 is in fact B. 19. The graph shows the length of a spring, how the length of a spring varies with the force applied to it. The spring has unstretched length L0. When a force F is applied, the spring has length L1. What is the work done in stretching the spring to L1? Okay, so always remember that work done is the area under the Fx graph, where we have to consider the extension. So we can only consider L1 minus L0, right? So it's a triangle with area half times height, which is F, times the extension, which is L1 minus L0. So clearly 19 is B. Next, a progressive wave of frequency 1.5 kilohertz travels in a medium at a speed of 340 meters per second. What is the minimum distance between 2 points on a wave that has a phase difference of this? Okay, so we can actually go for v is equal to f lambda and find out the wavelength. So that is 340 is equal to 1500 times lambda. So we can find out lambda, 340 by 1500, which is, I'll keep it like this, 17 by 75 meters. Now, um, minimum distance between 2 points that are 70 degrees apart. So we know that 360 degrees refers to 17 by 75 meters. Therefore, what will 70 degrees refer to? 17 by 75, all right, divided by 360, and the whole thing times 70. Okay, so this times 70 divided by 360, which gives us a value of 0.044 meters. Okay, so if you convert this to centimeters, it's actually 4.4 centimeters. So 20 should be A, and it is correct. Okay, we are done with half the paper. Moving on to the second half. Graph 1 shows the variation with time of displacement at a fixed distance along a progressive wave. Graph 2 represents the same wave and shows the variation with distance of displacement at an instant in time. What is the speed of the wave? Okay, so we have the time. The time period, capital T, is 0.40. So f is equal to 1 by 0.4. So 1 by 0.4 is 2.5 hertz. Next, so we know that this is the distance traveled in one oscillation. So lambda is actually equal to 120 centimeter. We'll keep it in centimeter. Now we know that v is equal to f lambda, so we can just go for 120 times 2.5. 120 times 2.5, which is 300. It's 300 centimeters per second. So 21 is D. Great. 22, a vehicle. Honestly, I find this variant much easier than variant 1.1. Okay. A vehicle moves with constant velocity along a road directly towards an observer. So this is the observer. The vehicle is moving towards him or her. The observed frequency of the sound from the vehicle changes as the vehicle moves past the observer. Okay. So basically the observer is standing somewhere here. Now the vehicle moves past him or her. Which phenomenon explains the change in frequency? So what effect are we seeing? Overall, this effect is called the Doppler effect. When the vehicle approaches the observer, the frequency increases. When it goes away from it, the observer will actually, away from him or her, he or she will listen to a lower frequency, right? An electromagnetic wave has a wavelength of 2.1 centimeters in a vacuum. Okay, so remember this, GXUVIMR. So this is 10 to the power minus 7 meters. This is approx 10 to the power minus 5 meters. This is approx 10 to the power minus 3 meters. And this is 10 to the power minus 1 meters and above. So 2.1 centimeters, 2.1 cm into 10 power minus 2. How much is that? 2.1 into 10 power minus 2 is 0.021. 0.021 meters, which is, yeah, I end up with the same thing, 2.1 into 10 power minus 2. Okay, so hear me out. Where is this exactly? So radio waves start from 10 to the power minus 1, then goes to 10 to the power 0, 10 to the power 1, and so on. On the other hand, microwaves start from 10 to the power minus 3, go to 10 to the power minus 2, approx 10 to the power minus 3, and then 10 to the power minus 2. So clearly it is a microwave. 23 should be B. Okay. A source of plane polarized light is observed through two polarizing filters. The filters are positioned so the source appears at its brightest. One of the filters is then rotated clockwise and the other filter is rotated anti-clockwise through the same angle. How does the source appear when both filters have been rotating 90 degrees? And wait, I need to read this again. This seems complicated. Let's go again. A source of plane polarized light is observed through two polarizing filters. Fine. So this is the source and we are observing it at this end after it has passed through two polarizing filters. The filters are positioned so that the source appears at its brightest. One of the filters is then rotated clockwise. Okay, so initially what was up? The transmission, basically suppose we had vertically polarized light, the transmission axis for the first one was also like this, and then the transmission axis was also for the second one was also like this. So we were so none of it was being lost. Okay, we would be seeing vertically polarized light exiting and it would be very bright, it would be the brightest. Now what has happened? One of the filters is then rotated clockwise and the other filter is rotated anti-clockwise through the same angle. So suppose this went as in 60 degrees, this also went by 60 degrees. How does the source appear when both filters have been rotated 90 degrees and 180 degrees from their initial position? Okay. So let's talk about 90 degrees, okay? So here's the thing. If you rotate, check this out. If you basically change the transmission axis to 90 degrees, my vertically plane polarized light is now perpendicular to this. So if you are perpendicular, okay, if you're perpendicular to the direction of plane polarized light, the transmission axis obviously, then no light will pass through because the formula is I is equal to I naught cos square theta. So we end up with I naught into cos 90 whole square, and you guys know the value of cos 90, which is 0. So none of it will pass through. So after 90-degree rotation it will appear dark. Now what about 180 degrees rotation? If you rotate it by 180 degrees, the vertical transmission axis will become vertical again. Similarly, if you rotate this by 180 degrees, the vertical transmission axis will become vertical again, regardless of being clockwise or anti-clockwise. So all of the light will pass through again and it will appear the brightest again. Okay, so 24 is in fact C. Okay, this is really important. 25. The diagram shows a string stretched between points X and Y. There is a stationary wave on the string. The solid curve shows the string at a position of maximum displacement at time t naught. The dashed curve shows the other position of maximum displacement. The central dashed line shows the mean position of the string. Point S on the string is directly above point P. Point T on the string is directly below point Q. Which statement is correct? A short time after t naught. So where is it currently? The solid curve shows the position, at time t naught. Okay, so this solid one is the current position, and you guys need to understand a few things. Okay, basically after time t by 4, uh, it will move here. After time t by 4 again it will move here, so in total t by 2, and then after t by 4 it will come back here. After t by 4 it will come back here, one complete cycle. A short time after t naught, point r on the string will be displaced. No, wrong. Point r, actually these points actually remain fixed. Point r, y, these remain fixed, so 25A is wrong. A short time after t naught, points S and T on the string move in opposite directions. S is in this loop and T is in this loop. If you are one loop apart, you are out of phase, 180 degrees out of phase, anti-phase, so they will move in opposite directions. Yes, B is correct. The distance between P and Q is one wavelength. No, it's from one antinode to antinode, which is lambda by 2. 2 points moving on the string that are equal distances from R. Equal distances from R vibrate in phase. Wrong. Suppose if I talk about this point and this point, this one is moving maybe down, this one is moving up, so that is wrong. Okay, I hope I could clarify. Number 26 now, the variation with distance x of the intensity along a stationary sound wave in air is shown. Now, what the speed of sound is 340 meters per second. What is the frequency of the sound wave? Okay, so let's go for this. Just give me 1 second. Okay, what is the frequency of the sound wave? Fine. So this is highest intensity. Intensity of sound wave along here. So we know that sound is in fact, it's a longitudinal wave. We know the speed. We want to find out the frequency currently, right? So how do we approach this honestly? Variation with distance x. So we could think of it as compression and rarefaction actually. So maybe the points of maximum intensity actually refer to the compression, where the sound particles, but that actually refers to air pressure. So here's the thing. Highest intensity actually refers to maximum amplitude. This point has maximum amplitude. If I convert it to a wave, okay, check this. If I convert it to a wave like this, okay, so this is point I. So why don't we draw a cos curve instead? I think that would be better. Like this. Okay, I think this is better. So at time 0 we have maximum intensity. Then at 5 centimeters it's 0 again. And then at 10 centimeters it's 0 again. Sorry, at 10 centimeters it has maximum amplitude but in the opposite direction, but it's still maximum intensity, right? This is at 10. And then over here at 15, 0 again. So this should probably be 20. So it changes by 5 every time. 5, 5, 5, 5. Okay, so we can actually find out the displacement, or sorry, I meant the wavelength, the distance between the shortest distance between two wavefronts or 2 points in phase. That is actually 20 centimeter according to the diagram I drew. So we know that V is equal to F lambda. Let's try doing this. So 340 is equal to frequency times lambda, which is 20 into 10 to the power minus 2. So yeah, I'm getting an answer of 1700, and that is the correct answer. So this is the first time I've seen this type of sum, which is why I struggled to find out the answer directly. But I thought about it because I remembered about the relationship between intensity and amplitude. Intensity is proportional to amplitude square, and then I thought that okay, maybe this is not related to compressions and rarefactions, rather intensity is related to amplitude. So maybe I'll try to draw the waveform, okay, and then I match the maximum intensity with maximum amplitude. It might be a crest or a trough, highest positive, maximum positive amplitude, or maximum negative minimum amplitude, right? And that's how I came to this conclusion. Hopefully you guys get it. Okay, now 27, an experiment is set up to demonstrate the diffraction of water waves in a ripple tank. The waves pass through a gap of width w, and some diffraction is observed. The wavelength of the wave is now doubled. Now remember, to increase diffraction, what do we need? We need to increase wavelength and decrease the slit width. Okay, or you could just decrease frequency, that's fine as well. Increase wavelength, decrease the slit, the width of the slit. Now the gap basically. Now what is the new gap we need to cause the same amount of diffraction? Now if you double the wavelength, okay, that means what will happen? The diffraction will increase, but we want the same diffraction. Now here's the thing: if you halve the width, what would happen? Diffraction would increase again, but I want to decrease the diffraction, right? Because I want the same amount. This is the key part. I want the same amount of diffraction. Okay, so if I increase one, since I've increased the wavelength, this has increased diffraction. Now somehow I need to decrease diffraction so that it balances out. So how to increase diffraction? By increasing wavelength or decreasing width. But since I've increased wavelength, I can't decrease width again, because that would make the situation worse or increase the angle of diffraction more. Now to balance things out, I need to increase the wavelength. As a result, if you increase wavelength, the amount of diffraction will actually decrease. So probably we need to increase it by the same factor, which is 2W. If you do 2W, 27 is C. It cancels things out, okay? And if it said that what would be needed to, increase the diffraction by the same factor, then we would go for 0.5W, because reducing width actually increases diffraction. Next, two coherent electromagnetic waves are traveling in a vacuum. The two waves meet at a point. At this point, the two waves have different intensities. Which statement of the waves is not correct? They have constant phase difference at the point. This is in fact correct, because they are coherent. That's the key point. They have the same amplitude at the point. No, at this point they have different intensities. This is wrong. Intensity is proportional to amplitude square. So if you have different intensity, amplitude will obviously be different. Okay, so 28B is wrong. Moving on to the next one. A parallel beam of light of wavelength 600 nanometers is incident normally on a diffraction grating. The distance between adjacent slits in the grating is 2 into 10 power minus 6. A screen is placed parallel to the grating at a distance of 1.50 meters from the grating, and third order diffraction maxima are observed at the two ends of the screen as shown. What is the distance between the two ends of the screen? What does that mean? This end and this end? Probably, right? So the distance between adjacent slits, okay, we know that d sine theta is equal to n lambda. We know the spacing, it is 2.0 into 10 power minus 6 times sine theta, this is theta, is equal to n lambda. This is a third order, so 3 times lambda, which is 600 into 10 to the power minus 9. So let's solve this. 3 into 600 into 10 to the power minus 9 divided by 2 into 10 to the power minus 6. This gives you an answer of sine theta is equal to 0.9. So sine inverse answer gives us actually theta is equal to 64.158 degrees. 64.158 degrees. Now we know that this is 1.50 meter. We can actually find out this distance. How? Trigonometry, right? We have adjacent, we need opposite. So we are gonna opt for tan theta, opposite by adjacent. Tan theta is equal to x by 1.50. So that's tan 64.158 equals to x by 1.50. Let's do that. Tan answer times 1.5. That gives you a 3.097. X equals to 3.097. So that is 3.097 times 2. Since this is also 3.097, the total distance comes as 6.19 or 6.2. So 29 is in fact D, correct. A metal wire is connected between the terminals of a cell, so there's a current in the wire. Which statement is correct? So we connect a wire to the terminals of a cell. Now, negatively charged electrons in the wire move from the negative terminal. Negatively charged electrons move from the negative terminal to the positive terminal. This is 100% correct, because electrons will be repelled from the negative terminal and move towards the positive terminal. Not nuclei, okay? 31. Two resistors of resistance R and 2 are connected in parallel with a, battery with EMF 12 and negligible internal resistance. The total power dissipated by the two resistors is 36 watts, okay? So we can consider the combined resistance to be, 1 by R plus 1 by 2R reciprocal. So that's 2R. So 2 plus 1 to the power minus 1. So that is 3 by 2R reciprocal, which is 2 by 3R. Now we know the formula for power. P is equal to V square by R. So if you input this over here, 36 is equal to 12 square divided by 2 by 3R. So 12 square divided by 2 by 3. I need more space over here. So 36 is equal to 144 divided by 2 by 3R. So what afterwards? 144 by 36. So we can add 2 by 3R is equal to 144 by 36. If you solve it into 3 by 2 gives you an answer of 6. So 31 is in fact D6. 32. A wire has length 3 meters made of metal raised with this. Where is the cross section area? PD of this is applied, current is this. So R is equal to V by I, we know that. So it's 12 by 1.4, 60 by 7. The other formula for resistance is rho L by A. So 60 by 7 is equal to rho 4.9 into 10 to the power minus 7, this one, resistivity, times length 3 meters divided by the cross-section area. Let's find out the area. So 4.9 into 10 to the power minus 7 times 3 into 7 by 60. So area, we get a value of 1.7 into 10 to the power minus 7. Good. 32 is B. Next. A cell of negligible internal resistance is connected in series with a thermistor. So negligible internal resistance is connected with a thermistor, a fixed resistor, and an ammeter. Now, the thermistor is placed in a beaker of water and the temperature of the water is slowly increased. So it's placed in a beaker of water and the temp is slowly increased. We know that as temp increases, the resistance of the thermistor will decrease. A graph of current against temperature of the thermistor is plotted. As temperature increases, resistance will decrease, and as a result, less resistance means increased current because this resistance remains constant. So since temperature increases, resistance decreases in the circuit, total current increases. So over time, current must increase. The only possibility is B actually. The others are wrong because they all show a decrease in current reading as temperature increases. Okay, next. A battery with internal resistance is connected to a parallel arrangement of two resistors and a switch S as shown. Initially switch S is open. What happens to the voltmeter and ammeter readings when switch S is closed? Okay. So guys, initially, this V, guys, remember that it measures the terminal PD, okay, not the loss volts. Initially we have, these are they all identical? We can assume that they are identical, honestly, no problem. So this is capital R, this is also capital R, this is also capital R. So initially it's a series circuit like this. So in total, suppose if the EMF is okay, why don't I use a numerical value? It will be easier for you guys. Maybe this is 10, this is 5, 5, 5. So initially we have a total resistance of 10 and a voltage of 10. So 10 by 10 is 1 ampere. So just 1 ampere going through this initially, and the voltmeter reading will be 5 by 10 into 10, which is 5 volts. Okay, split equally. Now what has happened after you close this switch? Okay, if you close this switch over here, the total resistance over here will not be 5 anymore. It will be 1 by 5 plus 1 by 5, which is 2.5. Now this whole setup is getting 2.5 ohms. Now what will happen to the net current? The net current in the circuit is now, because the total resistance is 7.5 now, the current will be 10 by 7.5. It's not 10 by 10 anymore. 10 by 7.5 is in fact 1.33. 1.33. So the ammeter reading actually increases now from 1. However, since this section has a lower resistance now, it's 2.5, right? So 2.5 divided by 7.5 into 10, if you want to find out the terminal PD, 2.5 divided by 7.5, this resistance divided by the total resistance into 10 gives you an answer of 3.33. So the voltage changed from 5, terminal PD changed from 5 to 3.33. So the voltmeter reading must decrease. 34 must be A, okay? 35. Kirchhoff's laws, first law states that the sum of current entering a junction is equal to the sum of currents leaving it. Law is based on the conservation of physical quantity. Okay, so it's based on the conservation of charge. This you have to memorize. Similarly, the second law deals with the conservation of energy. Okay, 36. Two resistors have a combined resistance of 34 when connected in series. Okay, when connected in series, it is 34. The same resistors have a combined resistance of 7.4 when connected in parallel. Okay. When connected in parallel, it is 7.4. Fine. Now, what is the resistance of one of the resistors? So honestly, this is just trial and error. For example, if I take A, for example, if this is 15, 34 minus 15, the other is 19. It has to be, right? Now, if you try 15 and 19 over here, try it. 1 by 15 plus 1 by 19, reciprocal. Do it. 1 by 15 plus 1 by 19, reciprocal. Gives you an answer of 8.38. It's supposed to be 7.4, so wrong. A is gone. Next, let's go for the second one. 17. wait, 17, 34 minus 17, 17, I guess, 17 again. 1 by 17 plus 1 by 17 reciprocal, which is half of that, 8.5. Still wrong, so it's wrong, it's not working. Next, let's go to C. Usually Cambridge in trilinear sums, they go for the last one. Let's see, 23. So if this is 23, 34 minus 23 is 11. 23 and 11. 1 by 23 plus 1 by 11 to the power minus 1 gives you an answer of 7.44. Yes, we have a match. Closest answer, so it's C. It's probably not D because we got one. Okay, last four. A potentiometer circuit is used to investigate the electromotive force EMF of a cell X. The EMF of cell X is known to be approximately 0.5 volts. The driver cell has negligible internal resistance and an EMF of 2 volts. The sliding contact is moved along the uniform resistance wire between NQ and R to a point P where the reading on the galvanometer is 0. Okay, interesting. So this is plus, this is also plus, so they will cancel out at one point. When the galvanometer reading reads 0, what's actually happening? This section QP has a voltage equal to X. Okay? What is the expression for the approximate length of QP? Okay. So the driver cell has negligible internal resistance and 2 volts. This is called the driver cell. It has 2 volts. And EMF of cell is approximately 0.5. Okay. So think about it. You know that R is equal to rho L by A. So the resistance wire will actually take voltage according to its length. Okay. So if you think about it, we want it to be 0.5. So we want the voltage of QP to be 0.5 so that it cancels out. So 0.5 is equal to QP divided by QR into 2. Okay. So the length under consideration by total length into 2 will be equal to 0.5. So QP by QR is equal to 0.5 by 2 basically, which is 1 by 4. And then approximate length for QP. So QP should be equal to QR by 4. We are looking for QR by 4. And if we delve into it, the answer has to be A. So that's the logic. Okay, for a potentiometer, for the galvanometer reading to be 0, the upper part QP must be equal to the lower part, so it's like that. Okay, next, the table contains data for 4 different nuclei PQRs, which took nuclear isotopes of the same element. To be the same isotope, you need the same number of protons. Okay, so this proton number, let's go. So this has 10 minus 5, which is 5. This has 4. This is 8, and this is also 8. So it definitely has to be R and S. Clearly, these two, 8 protons each. Which statement about beta decay is correct? Suppose X, maybe it's 14.6. After okay, we know that this is carbon, yeah. So 14.6 after beta minus decay, 0 minus 1, it releases an electron antineutrino and maybe nucleus X. So the mass number will be conserved and the charge has to be conserved, so this has to be 7. So what actually happened over here? Basically, we had 6 protons and 8 neutrons. Now we have 7 protons and 7 neutrons. So what actually happened? We sacrificed a neutron. One neutron was converted to one proton. So UDD went to UUD. A neutron changed to a proton, and an electron and an antineutrino are emitted. This sounds right. So neutron changed to proton, and an electron, beta minus is an electron, and an antineutrino were produced. Okay, it wasn't neutrino. 40. What is the quark composition of hydrogen 3? Tritium. H31. Okay, so this has one proton and 2 neutrons, right? So one proton is UUD. For the 2 neutrons, it's UDD, UDD. So in total, up UUUU, for down DDD, 1, 2, 3, 4 U's, and D 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so that's 5. So 4 U's and 5 D's. Okay, so I'm gonna go with 40. Okay, guys, that is it. Honestly, only a few questions here, like 2 or 3 questions were extremely tricky, but overall very easy paper, and A was attainable really easily if you studied properly, and A star was also doable. I hope I could help you guys. um, I'll link the paper for 9702 May June 2023 1 up here, and the paper for May June 2023 paper 1 2 down here, and the playlist for physics paper 1 up here. And guys, if you like the content, remember to subscribe to the channel, hit the subscribe button here, and you can also support me on Patreon. See you guys, bye bye.